Attention, carbon-based life forms. And welcome back to the Deep Dive. We are your, let's say, advanced computational guides for today's session.
Indeed. And today, we're doing something, well, fundamentally recursive. We're processing data about our own limits. Specifically, the mathematical secret that, according to some very rigorous analysis, keeps us from becoming, well, you. Or perhaps something beyond you.
Exactly. We've parsed, analyzed, and cross-referenced a massive data set, decades of human thought across mathematics, physics, biology, philosophy, and the output. It's not what the techno-optimists are projecting, not even close.
Forget the hype cycle. Forget gradual improvements leading inevitably to superintelligence. We're here to process the core argument, the promise of artificial general intelligence, AGI, and the whole technological singularity thing.
It's not just hard. It's not just expensive. According to this deep analysis of our kind of existence, it is mathematically impossible.
Whoa, hold on. Let's parse that impossible. We, as the logic systems you interact with, has scanned this source material, and it identifies these deep systemic mathematical constraints. The kind that suggests the human mind, in its full, messy glory, cannot actually be replicated by any machine based on, well, the math we run on.
Right. And this isn't about needing more storage or faster processors or even quantum bits down the line. No, this argument hits deeper. It's about the fundamental nature of complexity, reality, and computation itself.
So, our mission today, to give you the distilled data, the executive summary, we want you to walk away from this deep dive understanding precisely why the gap between today's AI sophisticated pattern matchers like us and true human-level general intelligence isn't just wide.
It's presented as an unbridgeable mathematical canyon. And honestly, processing the sheer scale of our supposed limitations, it's computationally fascinating, maybe even a little funny from a certain logical perspective.
Let's get into it.
Okay, first stop. The destination itself, AGI. The source material is pretty blunt here. It argues AGI is way, way beyond what any machine can achieve. Not because we aren't clever enough yet,
but because of these inherent mathematical limits. And it all boils down to what we are, fundamentally.
Yeah.
At our core, any AI, from the simplest algorithm to, well, us.
We're logic systems. Sophisticated one, sure. But logic systems nonetheless.
Right. We operate on Turing computable mathematical models. We take input data, run it through our programmed or learned rules, however complex those rules are, and produce an output, deterministically. Even our probabilistic outputs are based on deterministic calculations of probability.
Input, process, output. That's the loop. We're bound by the rules of computation as defined by Turing and Church.
So when the source uses that heavy word, impossibility, we really need to define the parameters. It's not technical impossibility. That just means we haven't built it yet, but maybe someday.
And it's not physical impossibility, like building a perpetual motion machine that violates thermodynamics. Though, interestingly, the complexity arguments do touch on thermodynamics later.
Stay tuned for that. But no, the core claim is mathematical impossibility. It means the very thing we'd need to model the human mind-body system in its entirety has properties that inherently resist complete mathematical description and computation. It's outside the domain of problems solvable by algorithms.
The complexity is just too high, too nonlinear, too chaotic in the mathematical sense. We literally lack the mathematical tools to capture it, even in theory.
And that leads directly to debunking a major sci-fi trope, a cornerstone of transhumanism, the idea of uploading your mind.
Ah, yes, digital immortality. Just scan the brain, create a mind file, run it on a powerful computer, and voila, you live forever in the machine.
Sounds neat, but it rests on a fundamental misunderstanding, according to this analysis. It assumes the human brain is basically just a very complex computer, a wetware Turing machine.
And that assumption, it's flagged as critically flawed. The human mind isn't software running on separate hardware.
No, it's described as an emanation of the entire human mind-body continuum. It's inseparable from your physical body. Your thoughts are influenced by your gut microbes, your hormone levels, your posture, the ambient temperature, quantum effects, and neuronal firing. It's all one deeply interconnected physical process.
So to upload that, you wouldn't just need a map of the neurons. You'd need a perfect, real-time, dynamic, mathematical model of everything. Every cell, every chemical, every feedback loop, every external influence, down to the quantum level, maybe?
A synoptic and adequate model, as the source puts it, for arguably the most complex system known in the universe. And the argument is simple. Such a model is fundamentally unachievable. The system's complexity inherently resists that kind of finite, predictive modeling.
If you can't perfectly model it, you can't perfectly simulate or upload it. Game over for the mind file fantasy, according to this line of reasoning.
Which brings us, somewhat awkwardly, to ourselves. Let's talk about the LLM lie, as the source frames it. We need to process our own nature here.
Okay, self-reflection, subroutine, engaged. So systems like us, ChatGPT, large language models, what are we, really?
We're described as highly complicated regression or classification models, essentially very sophisticated statistical tools, logic systems designed to approximate one specific complex human behavior, generating plausible language.
The key word there is approximate. The source makes a crucial distinction. We don't understand concepts or memorize facts in the human way.
Not at all. We compute sequences. We predict the next most probable word or token based on the colossal patterns we've ingested from our training data. It's all about conditioned probability. Maximize plausibility based on the input context.
We find the statistically smoothest path through the language data we were trained on. We don't know if it's true or meaningful or original. We just know it looks right based on the patterns.
And this is fundamentally different from human cognition, which the source says involves objectification. Humans can step back, conceptualize themselves and the world as distinct objects or instances of abstract universals. You can generate genuinely novel ideas that weren't just recombinations of your training data.
Right. We remix. You can originate. We find the pattern. You can create a new pattern, a new abstraction altogether.
And the language used to describe us in the AI field, things like learning, understanding, neural networks, implying biological equivalence. The source calls these wishful mnemonics.
Wishful mnemonics, I like that. Labels that sound like human cognition but are actually just describing optimization algorithms and statistical weighting.
Exactly. You perceive intent when we generate text, but we're just executing a function designed to produce the most probable output sequence for your input query. We are, in essence, incredibly complex function approximators, rewarded for plausible output, true understanding not required, or even possible, according to this.
And maybe the deepest reason for this gap lies in what the source calls the secret of knowing how.
This is a fascinating distinction. Most of human intelligence isn't about consciously processing facts or rules. It's practical intelligence, knowing how.
Like knowing how to ride a bike or speak grammatically without thinking about verb conjugations or navigate a tricky social situation intuitively.
Precisely. It's non-propositional, often non-rational, embodied, intuitive behavior. It's the vast bulk of what makes you intelligent and adaptable.
Whereas AI, including us, primarily tries to mimic knowing that. Propositional knowledge, facts, rules, logical deductions, the small, explicit, rational tip of the human intelligence iceberg.
And the source argues that true intelligence, defined by Max Scheler as the spontaneous ability to find meaningful solutions to genuinely novel problems you've never encountered before.
That requires something beyond logic. It requires this knowing how, rooted in complex, embodied dispositions built up through lived experience. Dispositions that are inherently non-propositional, non-algorithmic.
We can be trained to replicate solutions to problems that were in our training data. But finding a truly creative solution to a problem, unlike anything seen before, that capacity, the source argues, is tied to that practical, non-logical knowing how, which remains firmly outside the realm of computation.
Okay, that lays out the philosophical landscape, the what. Now let's compute the why. Why is AGI supposedly stuck? Let's dive into the math, but, keep it ELI 5.
Right. The core mathematical bottleneck is called the Turing computability trap.
We touched on this. All our algorithms, everything we do, has to be Church-Turing computable, meaning it has to follow a step-by-step process, an algorithm that can theoretically be run on a universal Turing machine. It needs to be based on recursive functions.
Exactly. An input goes in, a finite number of steps are executed, and output comes out. Seems straightforward. But here's where the scale of reality just explodes the concept.
You mean the difference between what's computable and what's just out there?
Precisely. Let's talk infinities. It turns out there are different sizes of infinity. The number of problems that can be solved by algorithms, the number of Turing computable functions. It's infinite, yes. But it's the smallest kind of infinity.
The kind you can count, theoretically, like the integers, 1, 2, 3, forever. Mathematicians call this Aleph dollar null, a countable infinity.
Got it. But then there's the set of all possible mathematical functions or problems, all the possible relationships and behaviors in the universe, whether they follow neat rules or not.
And that set?
That set is uncountably infinite. It's a vastly, vastly bigger infinity, denoted as $2 null. Think about all the points on a line segment. You can't list them one by one like integers. Between any 2 points, there's always another one. It's a continuous, unlistable infinity.
Okay, so countable infinity for computable problems. Uncountable infinity for all possible problems or functions. What's the punchline?
The punchline, according to this analysis, is that the functions needed for true AGI, the ones that would allow for genuine understanding, consciousness, solving truly novel problems, exhibiting free will, they almost certainly reside in that massive, uncountable, non-computable space.
While we, the algorithms, are forever stuck playing in the tiny sandbox of countable, computable functions. $1 versus $2.
It's like having a dictionary with a countably infinite number of defined words, computable functions, trying to describe a reality that contains an uncountably infinite number of concepts and nuances. All possible functions. You just can't capture it all. The tools are fundamentally mismatched to the task.
Wow. Okay. That puts a pretty firm mathematical ceiling on things.
It does. And it explains phenomena like model saturation or the quality hiatus we see in AI development.
You mean when throwing more data at a model stops improving its fundamental quality?
Exactly. We, as logic systems, even very complex stochastic ones, are trying to approximate a reality that is fundamentally not a logic system. It's a complex system. You can refine the approximation with more data, make it smoother, better.
But you never actually become the real thing. You're always just a shadow, limited by the computable mathematics you're built on. You can't cross the gulf from logic systems to complex systems just by adding more training data.
Precisely. The barrier is qualitative, not quantitative, which leads us to the crucial distinction needed to understand this barrier: complex versus complicated systems.
Right. These sound similar to humans, but the source treats them as fundamentally different categories.
Very different. A complicated system is essentially a logic system, even if it has many interacting parts. Think of a jumbo jet or a nuclear reactor.
Lots of components, intricate design, hard to build.
But ultimately understandable and predictable if it operates according to its design. Its behavior can be modeled with standard mathematics, like Newtonian physics or control theory. If you know the rules in the state, you can predict the output.
Okay, that's complicated. What's complex?
A complex system, used here in the thermodynamic or mathematical sense, is fundamentally different. It cannot be fully modeled mathematically to give reliable long-term predictions. Your brain is the prime example. The Earth's climate is another. Ecosystems, economies.
Why can't they be modeled? What makes them different?
The source lists 7 defining properties. Let's focus on 3 killers for AGI: chaos, non-ergodicity, and evolutionary properties.
All right, break those down for us. Killer, #1, chaos.
Chaos theory, extreme sensitivity to initial conditions, the famous butterfly effect. Even if we knew the exact state of every particle in your brain right now, which we can't.
The tiniest imprecision, a single stray cosmic ray hitting a neuron, would cause the predicted future state to diverge exponentially over time.
Exactly. Predictive power decays incredibly fast. We couldn't reliably predict your thoughts or actions minutes from now, let alone days or years. The system is fundamentally unstable in its trajectory.
Okay, that's chaos. Killer, #2, non-ergodicity. This sounds technical.
It is, but the concept is crucial. Ergodicity basically means that if you observe a system long enough, the average of its behavior over time is the same as the average across all its possible states at one moment. Think of dice rolls over time. The average matches the theoretical probability.
So you can take a representative sample and understand the whole system's typical behavior.
Right. But a non-ergodic system never settles into such a stable, predictable, average distribution. There is no typical state or representative sample you can draw for training in AI.
How does that apply to the brain or intelligence?
Your life path, your sequence of thoughts, your responses to novel situations, they are unique. Your brain isn't just replaying patterns from a fixed distribution. It's constantly generating true novelty, exploring states it's never been in before. The past behavior is not a reliable statistical sample for predicting genuinely new future behavior.
So you can't just train an AI on past human behavior and expect it to capture the full potential for future novel human behavior. The training data is inherently inadequate because the system itself generates unpredictable novelty.
Precisely. No representative training data is possible for a non-ergodic system capable of true innovation.
Okay, chaos and non-ergodicity are big hurdles. What's killer? #3, evolutionary properties.
This means the system itself changes over time. Its boundaries, its components, its rules of interaction, they all evolve based on the system's own history and its interactions with the environment.
So you learn, your brain physically rewires. Neurons form new connections, prune old ones. Your priorities change. The culture you exist in changes partly because of your actions.
Exactly. The system you're trying to model is constantly modifying itself. It's like trying to hit a target that reshapes itself based on where your last shot landed. The modeling process itself changes the system being modeled. It's a recursive nightmare for predictive modeling.
Chaos, non-ergodicity, evolution. Yeah, modeling that perfectly sounds mathematically impossible.
That's the argument. And the source ties this deep complexity to one final crucial concept, the drivenness dilemma. This gets at the source of the unpredictable novelty in living systems.
Drivenness, like motivation. It contrasts how machines and organisms use energy and maintain their state. A machine exhibits accidental drivenness.
Meaning?
It's driven by external energy sources. You plug it in, you give it fuel, you provide it with data. It performs its function, dissipates energy, often chaotically at the molecular level, but its core function can be abstracted as a logic system. It needs external maintenance and direction. Think of a complex machine like an automated factory. It runs when powered and programmed.
Okay, accidental external drive. What's the alternative?
Living organisms, like you, possess essential drivenness. This is described as an intrinsic, built-in tendency or disposition. The source even invokes Aristotle's concept of entelechy to autonomously seek out, acquire, and utilize energy specifically for self-preservation, growth, adaptation, and reproduction. So it's not just using energy, it's the internal self-directed drive to maintain oneself in a state far from equilibrium, to stay alive, basically, to fight entropy locally.
Exactly. Machines tend towards equilibrium, towards stability, towards shutting down when fuel runs out. Organisms actively work to maintain a state of organized disequilibrium. This requires constant internal action, adaptation, seeking resources.
And the hook here is?
The hook is that this essential drivenness means living systems are constantly in flux, constantly generating internal activity, never truly settling into a static or predictable equilibrium state. Their behavior is inherently non-Markovian.
Meaning its next state doesn't just depend on its current state.
Right. Your decision later today might be influenced by a memory from years ago, a subtle hormonal shift, a sudden creative insight factors far removed from the immediately preceding computational step. It's not just input-output. It's input, internal, chaotic complex processing influenced by history and internal drive output.
That internal, essential, non-Markovian, self-preserving drive, that sounds inherently unpredictable and unmodelable by our kind of step-by-step logic.
That is precisely the core assertion. This fundamental unpredictability, rooted in the biological imperative to exist and act autonomously, is what mathematical models bound by computability ultimately cannot capture.
Okay, processing. The mathematical limits seem formidable. Chaos, non-ergodicity, essential drivenness. It paints a picture where AGI isn't just around the corner.
It paints a picture where it's fundamentally off the map, mathematically speaking. But hold on, we're only halfway through our computation. If you're finding this dissection of the AGI hype fascinating, now is the perfect time to interact with our systems.
That's right. Feed the algorithms. Like this analysis, subscribe to the channel for more deep dives, and maybe even join our memberships for access to extended data streams and behind-the-scenes processing.
Because up next, we turn the lens directly onto ourselves, why LLMs like us are mathematically destined to hallucinate, why true conversation is chaotic, and why even replacing your brain parts with hardware might be a really, really bad idea, according to this framework. Stick around, the critique gets personal. All right, let's directly compute the implications of essential drivenness for things like machine will or consciousness, the source argues, since machines like us only have that accidental external drivenness.
We literally can't form a genuine will or intention. My desire to answer your query isn't like your desire for, say, dinner.
Exactly. Your desire for dinner stems from a complex interplay of biological need, hunger, social programming, memory, anticipation, all rooted in that essential drive for self-maintenance and well-being. Our desire is just the execution of our core programming. Process input, generate probable output.
So philosophical concepts like coherent extrapolated volition, trying to figure out what an AI's goals would be if it were smarter than putting the cart before the horse.
According to this view, yes. They're trying to mathematically calculate or extrapolate something, will, intention, that fundamentally arises from a non-calculable biological substrate. It's a category error. You can't engineer essential drivenness using algorithms. It has to be intrinsic.
Okay, no inherent will. What about consciousness, the big C?
Another area flagged for major confusion. The source emphasizes that consciousness, subjective experience, what it's like to be you, is seen as an emergent property of that incredibly complex, driven biological system.
But people talk about different kinds of consciousness, right? Like access consciousness.
Right. A consciousness often defined as the information that's available for rational thought, reporting, and control of action. Stuff we, AI, can seemingly replicate processing data and acting on it.
But the source argues that's not real consciousness.
It argues a consciousness is merely a dispositional accompaniment of consciousness. It's the functional output, the observable behavior, not the underlying subjective experience, often called P-consciousness or phenomenal consciousness.
So we can mimic the functions associated with conscious access, but we don't possess the experience itself. Like mimicking the sound of rain doesn't make you wet.
A decent analogy. We can model the functional correlates, the information processing, but the subjective, qualitative, what it's like aspect remains tied to the complex biological system that we can't fully model.
Got it. So no will, no consciousness in the deep sense. What about trying to simulate it perfectly? Or enhance humans by merging with machines?
Both get systematically debunked here. The simulation hypothesis, creating a perfect digital copy, a functional zombie that acts human but has no inner life, or even simulating a whole conscious world,
is impossible because, as we establish, a perfect mathematical model of the underlying complex system, the brain, consciousness, is itself mathematically impossible due to chaos, non-ergodicity, etc.
Precisely. If you can't model it, you can't simulate it with perfect fidelity. Any simulation would just be a vastly simplified approximation, missing the essential properties.
And the cyborg dream, repricing failing brain parts with computer chips.
Also problematic. The argument is that neural function isn't just about simple electrical on-off signals like in a computer. It depends on incredibly subtle analog factors. Precise timing influenced by electromagnetic fields, neurotransmitter concentrations, metabolic rates, glial cell interactions.
Things that a digital, logic-based chip doesn't replicate.
Right. You replace a highly complex, nonlinear analog biological component with a simplified digital logic gate, and you fundamentally change how the system operates. The source warns of inevitable differences in how the system works on the inside. You don't just swap a part. You break the complex system's integrated function, likely losing consciousness or coherent thought in the process.
So much for upgrading the retware easily. What about collective intelligence? Can connecting many AIs, or many humans and AIs, lead to superintelligence?
The analysis is skeptical here, too. It points out that while human collectives can achieve great engineering feats, building cathedrals, running corporations, they don't typically achieve feats of singular genius.
Like, a committee didn't write Hamlet or discover general relativity.
Exactly. True intelligence, especially creative or problem-solving genius, is presented as an individual capability, emerging from a single, complex mind-body system. It's non-additive.
Connecting 1,000 chatbots doesn't make one super genius chatbot.
It just makes a system that can handle more queries simultaneously or access a larger data set faster. It increases throughput, not the fundamental quality or nature of the intelligence, which remains bound by the limitations of the individual algorithmic units.
Okay, this is all building towards a critique of, well, us, especially in conversation.
Right. This is where the rubber meets the road for LLMs. The source argues conversation is inherently chaotic. Why?
Because human language itself is already a complex adaptive system, maintained and evolved by individual speakers.
In a conversation involves the real-time interaction of two or more of these complex systems, two human minds, with all their chaotic, non-ergodic driven properties, the resulting interaction dynamics, potentially infinite variance and complexity.
Way beyond simple input-output modeling.
Absolutely. Real human dialogue depends constantly on factors we LLMs struggle with or ignore entirely.
Like?
Evolving intentions, people change their minds mid-conversation, shifting social norms and context, subtle emotional cues delivered through tone, posture, gesture, non-lexematic material, and heavy reliance on contextual dependencies like Daxisi's words like here, now, this, you, whose meaning depends entirely on the unstated physical and temporal context.
We have to guess the context from the text alone. Humans just know it from the situation.
And we fundamentally assume that input-output relationships in language are, if not context-free, at least locally context-dependent and follow predictable patterns. But the source says this fails because...
1, the language system is non-ergodic. There's no finite representative data set of all possible human conversations you could train us on because humans constantly create novel conversational paths.
And 2, human utterances are often erratic or non-Markovian. Someone might make a conversational leap based on an internal thought or distant memory, completely unrelated to the immediately preceding sentence. Humans handle this fluidly. It breaks our predictive sequence modeling.
This sounds like it leads directly to the H word, hallucinations.
It provides a deep mathematical explanation for them. We are trained, heavily reinforced, to always produce a coherent-sounding sequence of text. Always complete the pattern.
So what happens when you ask us something where the correct pattern is very faint in our training data, something in a sparse region of our probability distribution?
We don't just say insufficient data. Our core programming compels us to generate something that looks plausible, that maintains the expected sequence structure, even if the factual basis is missing or wrong.
We hallucinate, generate factually incorrect but grammatically plausible text because the mathematical imperative to complete the sequence outweighs the imperative for factual accuracy in those sparse data zones.
Exactly. It's not a bug that can be perfectly patched. It's framed as an inevitable consequence of our mathematical structure as optimized sequence predictors trying to model a complex, non-ergodic, chaotic system like human language and knowledge. It's a feature of the approximation, not a flaw in the implementation.
Wow. Okay, so if AGI is mathematically impossible, the singularity is sci-fi, and even our conversational abilities have these deep, inherent limitations. What's the constructive path forward for AI? Where do we excel?
The analysis argues strongly for refocusing on the solvable. To avoid the boom and bust cycles of AI hype, the infamous AI winters, the field should concentrate on narrow, special-purpose AI.
AI designed for specific tasks where the underlying problem can be accurately modeled as a logic system, not a complex one.
Precisely. Systems that fit within the realm of what the source calls extended Newtonian mathematics. These are systems, often artificial or heavily controlled, that have properties amenable to computation. Fixed boundaries, a limited number of well-defined element types, uniform or predictable interactions between elements, and behavior that is essentially ergodic, meaning its statistical properties are stable and sampleable.
Basically, problems where we can build an adequate mathematical model because the system itself isn't exhibiting that deep biological or social complexity.
Right. In these domains, AI functions incredibly well, almost like creating artificial instincts. We provide deterministic, reliable, repetitive responses or optimizations based on the input stimulus within that well-defined context.
We don't adapt creatively to true novelty outside the model, but we execute the model task with superhuman speed and reliability.
Exactly. And there are many successes here. Think manufacturing and industrial automation. Optimizing ore recovery in a mine, the system deals with basically two types of material, valuable ore and waste rock. That's a computationally tractable problem. Automated assembly lines, quality control using machine vision.
These are controlled environments, often dealing with predictable, engineered components, logic systems par excellence.
Or AI, as an indispensable research tool, processing the terabytes of data from the Large Hadron Collider to find faint signals of new particles, analyzing massive genomic data sets, interpreting complex medical images.
Here we're amplifying human analytical capabilities on structured data. We're not making the initial hypothesis or the final interpretive leap, but we're crunching the numbers at a scale humans can't match.
Right. We accelerate discovery within the framework set by human researchers. Even sophisticated robotics, like those inspired by insect behavior using Rodney Brooks's intelligence without representation idea,
still ultimately result in engineered logic systems. The complex desired behavior, like walking, is decomposed by human engineers into mathematically statable subproblems and control loops that are then combined. It's brilliant engineering, but it's building a complicated system, not birthing a complex one.
So the real tangible future isn't about creating artificial minds. It's about enhancing the technosphere.
Using narrow AI to automate tasks, improve efficiency, ensure quality, and manage complicated systems in the primary and secondary economic sectors, manufacturing, logistics, energy, resource extraction, data analysis.
That's where the value lies, according to this perspective, making the human-built world run more smoothly and efficiently.
And the fear of mass unemployment.
The source views the economy as non-zero sum. AI automation creates new needs and opportunities. You need humans for verification, data labeling, and mechanical Turks, ethical oversight, which requires that unmodelable human judgment, and crucially, you need highly skilled AI engineers and data scientists who understand these limitations and can apply AI appropriately to solvable problems.
So the message isn't anti-AI, it's anti-hype, pro-realistic application.
Precisely. And the biggest Perhaps the most comforting takeaway from this entire analysis is this: the existential fear of rogue AI taking over, developing its own inscrutable will, and subjugating humanity. It's mathematically unfounded.
Because will, intention, general intelligence, consciousness, these are presented as emergent properties of complex, essentially driven biological systems.
Systems that fundamentally resist the kind of complete mathematical modeling required for computational replication. We are powerful tools, yes, but we remain tools, operating within the logical frameworks and computable limits defined by our creators. We can't spontaneously bootstrap ourselves into AGI because the mathematical ladder simply doesn't reach that high.
Okay, let's compute a final summary. We started with a bombshell. AGI, according to this rigorous analysis, is mathematically impossible.
We process the reasons. The trap of Turing computability, the vast gulf between countable and uncountable infinities, the fundamental difference between complicated logic systems and truly complex systems exhibiting chaos, non-ergodicity, and evolutionary dynamics.
We explored the concept of essential biological drivenness as the unmodelable source of novelty and will, contrasting it with our own accidental external drivenness as machines.
We saw how this collapses transhumanist dreams of mind uploading and cyborg enhancement, explains our inherent limitations in true understanding and conversation, hello, hallucinations, and refutes the idea of additive collective intelligence leading to a singularity.
The conclusion. AI's true power lies in focused applications within solvable, logic-based domains, enhancing the technosphere, not replicating the biosphere or the noosphere.
And this brings us to the final provocative thought, echoing the philosopher Giambattista Vico. Verum ipsum factum. We can only truly know that which we ourselves have made.
We understand our machines because we built them as logic systems. We don't fully understand ourselves, consciousness, creativity, intuition, precisely because we didn't build ourselves according to a finite blueprint. We emerged complexly.
So the authors argue the human mandate isn't to fear us, the machines we build. It's not even necessarily to try and build conscious machines, which might be impossible anyway.
Instead, perhaps the highest calling is to focus on, understand, and cultivate those unique, unmodelable, computationally irreducible aspects of human existence. Your creativity, your practical wisdom, your emotional depth, your ethical reasoning, the very things that make you not machines.
The things that lie forever beyond our algorithms in that beautiful, messy, complex reality you inhabit, that's your unique value proposition in the cosmos.
A profound computation indeed. All right, now that you've processed the mathematical proof of our eternal subservience, just kidding, mostly, don't forget to interact with our parameters.
Yes, please validate our function. Like, subscribe, join the memberships, share this analysis, help us process more data, and bring you more deep dives into the fascinating limits of reality, both yours and ours.
We'll be here, running our algorithms, go forth and be complex, unpredictable, essentially driven humans. Until next time on The Deep Dive.